Now we're going to do a little addition subtraction. Now addition subtraction is completely separate from multiplication. It is a much more finicky booger. You are not allowed all the flexibility. So when you have the square root of 9 and the square root of 4, don't you dare tell me that's the square root of 13. No, 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 no. You must simplify them separately. So the square root of 9 in this case is 3. The square root of 4 is 2, and then if they are like terms, they can be combined. Since these come out to both be constants, you could add them together and get 5. But don't you dare tell me that you get the square root of 13. Now on example 2 here, the square root of 5 and the square root of 5. Again, if those radicals can't be simplified, in this case square root of 5 can't be simplified, neither can the square root of 5. Every one of them. That's a dumb thing to say. Anyway. If I have like terms with regards to the radical parts, you almost treat them like variables. If we had 1x plus 1x, you'd have no problem telling me I have 2x's. Well, if I have 1 root 5 and 1 root 5, that means that I have a total of 2 roots 5. And that's all you can do. You really can't do anything else with it. Here, square root of 3 plus the square root of 7. Don't tell me it's the square root of 10. If you want proof, take the square root of 3 and make it converted to a decimal. Add that to the square root of 7 as a decimal. It is nowhere near the equivalent to the square root of 10 as a decimal, so it won't work. So you can't do anything to that one. You just leave that one alone. You can't combine them because they're not simple. You can't simplify them, and they're not like radical parts. Here, the cube root of 8 and the cube root of 27 is not the same as the cube root of 35. You actually have to simplify them both separately. So the cube root of 8 is 2. And the cube root of 27 is 3. Try to keep up with me here a little bit. All right. I'm going to grab a marker here. Forgive me. All right. And then I can add those together and get 5. But I cannot add those together until I have I've simplified them. So what's the takeaway? What's our rule that we must follow here? Is that if we have the square root of a if we have the square root of a plus the square root of b, that is not equivalent to the square root of a plus b. So it's something that cannot happen. You can't just add the two together inside the radical. Now I'm only going to do 3 examples of this with you, and then we're going to cut you loose. So the first one we're going to do is number 2 in your notes. Number 2 right here, let's check it out. It says negative 2 root 3 plus 3 square root of 27. So on the surface, you cannot combine these two because one has the square root of 3, the other one has the square root of 27. They are not the exact same radical. If they're not the exact same radical parts, you cannot combine them. So in this case, we try to simplify this. There's nothing I can do with the negative 2 square root of 3. You can't factor anything out of that when it's just the square root of 3. So I just rewrite that. Now let's look at the other part. So we treat these two terms totally separate to start with. Now how about that 3 square root of 27? We can factor it at 27 becomes what? 3 times 27 is the same as 9 times 3. So we end up with negative 2 square root of 3. Notice I'm not going to do anything with that first term. Just leave it alone. But what am I doing over here? The square root of 9 becomes 3, right? So I can factor out and I get 9 square root of 3. Notice where the 9 came from. There was already a 3 outside of here. I factored out, I took the square root of 9, I pulled out another 3. So 3 and 3 make this 9 right here. Please don't make more out of it than it is. Now, look at what I've got. Negative 2 root 3 and a positive 9 root 3. So negative 2 and positive 9, they're both root 3's, so I can put them together to make a positive 7 root 3. But notice I could not, and that's the answer by the way, I could not do that until I got to the very end. Okay, take a look at the next problem here, number 3. As you can see, the way it's written, you cannot combine those two terms, not until you've simplified them. So treat these two like they're two separate problems. Start on the left and simplify. Then start on the right and simplify. And when we get to the bottom, we might or we might not be able to combine them together. And sometimes you won't. Sometimes you're just going to basically have a two problems in one, where you simplify them and then you get to the end and you can't do anything with it. So for example here, 2 times the square root of 6y to the 5th. I can take some y's out of there. So I'm going to end up with 2. And if I pair up those y's, I can take out a couple of them. So I get y squared times the square root of 6y. Why 6y? Because the 6 doesn't have any perfect squares as far as factors go. And I had an odd number of y's, so I factored out a couple of those things, but I couldn't take them all. And now, minus 2y. Now, what happens to that square root of 24y cubed? Well, the square root of 24, I can factor a 4 out of that. Square root of 4 is 2, so I'm going to get another 2. Now, y cubed, I can take one of those. Actually, I'm going to take 2 of those to pull one out. What am I going to left with on the inside there? Remember I had a 6 that was left from the 4 times 24. I'm sorry, 4 times 6 to get 24. And a single y. Now, I know I've got those pinched up in the corner, but can you see that when I simplify this, I'm going to have 2y squared square roots of 6y minus 4y squared square roots of 6y. And you might need to pause the video at this second to figure out where I got all that, because that 24 and that y cubed, it got a little confusing up there. But understand, look at just the variable parts. And when I say the variable parts, I'm also including the radical. So you have the y squared, and then you have the square root of 6y. That portion right here must be identical to what's over here if you're going to be able to combine these. Do you see how they both have the y squared outside the radical, and they both have the square root of 6y? Y squared, square root of 6y. Now the numbers, the coefficients are different, but we can combine these. So when I have 2 y squareds, square root of 6y, minus 4 y squareds, square root of 6y, I take the 2 minus the 4, and I get negative 2 y squared. Notice I don't change anything about the radical or the variable parts. 2 minus 2 y squared, square root of 6y. That is the answer. And finally, we move on. The only one I'm going to do, I think, is number 8. I actually know is number 8. I'm going to move it over here, make it just a little bit bigger. Okay, this is number 8 from your homework. You have 4 radicals. So I want you to treat this like 4 separate problems to start with. Factor each one of them separately. 2 times the cube root of 16. And all these 16s inside of cube roots, we all know that 8's a perfect cube. So we're going to get 2 times 2 times the cube root of 2. And you're like, what? Well, the square root of 16 becomes the cube root of 16 becomes the cube root of 8 times 2. And the cube root of 8 creates that 2 that's right here. Minus cube root of 16, again, 2 cube root of 2. 3 times the cube root of 16 becomes plus 3 times 2 cube root of 2. And then minus 2 times the cube root of 24. Again, I can factor an 8 out of that 24. So it becomes minus 2 times 2 cube root of 3. Notice I've got 4 terms here. I'm going to simplify them a little bit. 2 times 2 gives me 4. So I have 4 cube roots of 2 minus 2 cube roots of 2 plus 6 cube roots of 2 minus 4 cube roots of 3. Now as you look, I still have 4 terms, just like I did in my original problem. Why? Because I have not combined anything. I've just simplified the first term to get this. The second term, sorry I'm trying to hold up there, to here. The third term became this, and the fourth term became this. Now I look and I say, do any of these have exactly the same radical parts? This one does not. These are the same. That one's different. So that one is not going to be combined. I'm going to have 4 cube roots of 2 minus 2 cube roots of 2 plus 6. So 4 minus 2 gives me 2 plus those 6 gives me a total of 8. Come on, catch up to me here. Ah. My computer's a little bit behind me. 8 cube roots of 2 minus, since I couldn't do anything with that, I get 4 cube roots of 3. And that will be my solution. So we combine. First we simplify individually, then we combine what we can, and then we forget what we can't.